Hello everyone. In this video we talk about mesh analysis. First of all, mesh analysis is based on KVL, the summation of all the voltages around a loop equal to 0. That's why in mesh analysis we like to have voltage sources rather than current sources because we know the voltage of a voltage source. However, we don't write equations in terms of voltage of the elements because that way the number of unknowns is going to be more than number of equations and it's not solvable. Instead, we're going to write the equation in terms of currents of the meshes using Ohm's law. So in this way, then the number of equations is going to be equal to the number of unknowns and the equations are solvable. In lecture, we divided mesh analysis into 4 categories. Case 1, when there is no current source. Case 2, when there is a current source only in one mesh. Case number 3, current source between 2 meshes. We also call it supermesh. Case number 4, when we have a dependent source. For case number 4, first of all, we assume that dependent source is just like an independent source. So we decide if the mesh is case number 1, case number 2, or case number 3. And then because the dependent source has a controlling parameter, we have to write that controlling parameter in terms of currents of the mesh because the unknowns in the equations are the currents of the meshes. So assuming that this dependent source depends on some currents like Ix or voltage like Vx, look at the circuit and try to write Ix and Vx in terms of current of the meshes, which is our unknowns. So let me show you all of these 4 cases in an example. So using mesh analysis, first of all you have to identify the meshes. So in this circuit you see 4 meshes with current labels as I1, I2, I3 and I4. So if the currents are not labeled for the meshes, you have to label them yourself and show the direction of the current in each mesh. So you can assume counterclockwise or clockwise, but you have to be consistent. If you assume counterclockwise, you have to assume the direction of the current in all meshes counterclockwise. If it's clockwise, all the meshes the same thing. So here I have 4 meshes. So let's start with mesh number 1. Which case is mesh number 1? So if you look in mesh number 1, there are resistors and voltage source. So there is no current source. So in mesh analysis, we decide on cases on current sources. So there is no current source. So mesh number 1 is case 1. There is also a dependent source. So it's a voltage source and it's a dependent source. So first of all, I assume that it's just acting like independent source. So I decide between case 1, case 2, case 3, which is case 1. I write the equation and then I figure out the controlling parameter. So let's write the equation for mesh number 1. So it has all the unknowns, I1, I2, I3, and I4 in the equation. So the coefficient for I1, when I'm writing equation for mesh number 1, is all the resistors connect in that mesh, which here is 3, 12, and 8. So 3 plus 12 plus 8. The coefficient for all other currents, it's going to be what is shading between these mesh and other meshes. So mesh number 1 and mesh number 2, 12 ohm resistor is shading, so you write that with a negative sign. Mesh number 1 and mesh number 3, nothing is shading, so coefficient is 0. Mesh number 1 and mesh number 4, 8 ohm resistor is shading, so I write that with a negative sign. The other side of the equation, it's going to be all the voltage sources in that mesh. So for the sign, you check the direction of the current in that voltage source. So if you check the direction of I1 in the voltage source is entering the negative and exiting from the positive terminal, which is what I'm expecting for an active element. So it's going to be with positive sign, positive 5IA. Here IA is the controlling parameter for the dependent source. So you have to look at the circuit and find IA. So if you look, IA is here, which is the current for the 5 ohm resistor, which is located only in mesh number 3. So if you look, I3 has the same direction as IA and it's only in mesh number 3. So the only currents that going through that element is I3. So basically IA is I3. So you can substitute I3 instead of IA in this equation. Let's look at mesh number 2. So in mesh number 2, which case is it? You have to decide based on the current sources. Yes, in mesh number 2, there is a current source, and that current source, 2 amp current source, is only located in that mesh. So that would be case number 2, the easiest case to write the equation, and the current of that mesh must be same as the current of the current source, because the only currents that going through that current source is I2. But if you check the direction of I2 is opposite of the direction of this current source. So I2 is going to be negative 2 amp. And you don't need to write any other equation for that mesh because you already got I3, so no need to write KVL for that mesh. And it's not easy to write KVL because you don't know the voltage of the current source, and that's gonna add another unknown to the equation. So don't write any KVL for that mesh because it's not useful. Let's discuss on mesh number 4. Mesh number 3. Mesh number 3, there is a current source 5 amp and it's shading between mesh number 3 and mesh number 4. It's not only in mesh number 3. So mesh number 3 and mesh number 4 is a super mesh and it's case 3. So I have to write two equations for the super mesh. The first equation is the relationship between I3 and I4 related to the current source. So current source is between two meshes. So both current I4 and I3 are going through this current source. So if you check the direction, I4 is the same direction as the current source and I3 is different direction. So the equation, the super equation for the mesh is I4 minus I3 equal 5m. I need another equation for the super mesh, which is KVL for super mesh. Just like case 1, the equation in terms of current of the meshes has 4 unknowns, I1, I2, I3, and I4, and I have to figure out the coefficient for each of these currents. So let's start with I3 and I4, which is part of the super mesh. So here is my super mesh in the circuit. I3 and I4 is part of inside the super mesh. So the coefficient for I3, it's going to be all the resistor in mesh number 3 but not in mesh number 4, which is 5. The coefficient for I4, it's going to be all the resistor in mesh number 4 but not in mesh number 3, which is 4 plus 8. For the other currents, we check what is sharing with those currents and the super mesh. So I1 is sharing 8 ohm resistor with the super mesh, so the coefficient is going to be negative 8. I2 is not sharing anything with the super mesh. There is 18 volt voltage source, but we are looking for the resistor at this point, so it's going to be 0. The other side of the equation, it's going to be all the voltage sources in the super mesh. So there is 18 volt voltage source. So we have to check the direction of the current in that voltage source. So if you check I3, it's going from positive to negative. So this is I3. So going from positive to negative. So exiting from the negative terminal, that is not what I'm expecting from a positive, an active element. So I'm gonna write that with the negative sign, minus 18 volt. So here I have 4 equations, 1, 2, 3, 4, but basically I3 is minus 2, so I can substitute minus 2 into the other equations, and it's going to be 3 equations with 3 unknowns. There is a controlling parameter, which I already got that as I3, so it's solvable. So I hope that was helpful, and see you in the next video.